Let's look at some strategies for testing series. The first thing you always want to check is the nth term. If it approaches 0, then you move on. If it doesn't, the series diverges and you're done. Just stop. The next thing you want to look at, is it one of the special types? Is it geometric? Is it P? Is it telescoping? Is it alternating? If it is, then we know a little bit more about it. The third thing you want to check is the integral test, root test, or ratio test. Can these be applied? A lot of times a ratio test, that's always my go-to test. And it does fail, but it's one I usually go to. And the last thing I try is, can it be favorably compared to one of our special functions so that I can tell whether it converges or diverges. Now, here's just a review, summary of the tests. There is an entire video on the remainders. Here is another continuation of the summary of tests. Now let's see if we can try some. Applying the strategies for testing. Let's look at the sum as n goes from 1 to infinity of n plus 1 divided by 3n plus 1. Now, if a sub n is n plus 1 divided by 3n plus 1, the first thing I always want to do is look at the limit as n goes to infinity of a sub n, and in this case, it's a limit as n goes to infinity of n plus 1 divided by 3n plus 1, which is 1/3. This is not 0. So by the nth term test, and yes, you need to tell me what test it is. The sum as n goes from 1 to infinity of n plus 1 divided by 3n plus 1 diverges. Let's look at the sum as n goes from 1 to infinity of pi over 6 to the n. This is geometric. Where r is pi over 6. And r is less than 1. So, by geometric series test, I know that the sum as n goes from 1 to infinity of pi over 6 to the n converges. Oh, let's get a little bit more interesting. The sum as n goes from 1 to infinity of n e to the minus n squared. Well, let's let f of x equal x e to the minus x squared. I can integrate this from 1 to infinity. This is positive. So the integral from 1 to infinity of x e to the minus x squared dx, I'm going to do a u substitution. U is minus x squared, so du is minus 2x dx. U of 1 is minus 1, and then u of infinity, and I absolutely hate writing this, is minus infinity. So when I rewrite this, it becomes the integral from minus 1 to minus infinity of, let's see, I need x dx, so this is minus 1/2 du e to the minus x squared e to the u. So this is the limit as b approaches infinity of minus 1/2, the integral from minus 1 to b, and I've got a negative infinity there, of e to the u du. So this is minus 1/2, the limit as b approaches minus infinity of e to the u evaluated at minus 1 and b. So this is minus 1/2 times e to the b minus e to the minus 1. I forgot my limit, didn't I? B goes to minus infinity. Now this term, of course, goes to 0. So this is minus plus 1 over 2e. This converges. Therefore, by the integral test, the sum as n goes from 1 to infinity of n e to the minus n squared converges.